Hello and welcome. My name is Matt Taylor from Microcom Design. This is the third video in a GTX Quick Start series. In this video, we will be configuring the GTX to make timed transmissions. Continuing with the setup from the last video, we can now connect the GTX to the PC using an RS-232 cable. We can download the GTX utility from Microcom Design's website. This executable can be stored in a local folder where it can be run. Once we've got the GTX utility up and running, we can connect to the GTX by selecting the correct COM port. This can be done by clicking the Options menu and navigating to the COM port menu and selecting the correct COM port. I know that the GTX is connected to my PC's COM port number 1, so that's what I'm going to use. Now we can click the Configure/Control/Deploy GTX button so that we can begin configuring the GTX. Under the Configuration Options tab, enter the site's GOES Platform ID. I will be using Microcom's test ID, but you must use your own. Next, we will be moving on to the General Setup tab, where we can configure the configuration quantities. First, we will be configuring the internal sensors quantity of 1. This will be the battery voltage. Next, we can configure the STI-12 sensors. We will be using 3 STI-12 sensors. This will be the water level, water temperature, and air temperature. Next, we can configure the time data parameters. We will be sending 8 timed data parameters in the timed message. Lastly, we can click the Save button. We should also click the Enable for Transmission on Power Up checkbox. This checkbox allows the GTX to begin making transmissions after power up automatically. We can also check the Use / for null. This checkbox fills the null measurements with forward slashes. Now we can move into the Transmission Setup tab. Where we can begin setting up the timed transmission parameters. We can do this by checking the Enable Self-Timed Transmissions checkbox. I'm going to be using channel number 196. The transmission interval is going to be once an hour. The first transmission is going to be 9 minutes and 40 seconds after the top of the hour. Now we can set the window to 10 seconds. We change this from 5 seconds because the transmission is going to be longer than 5 seconds. This will set up the GTX to make a transmission every hour at 9 minutes and 40 seconds after the top of the hour on channel 196. We also want to be sure that the bit rate is set to 300 bits per second and the data format is set to WSC chef. We also want to be sure that the data source is coming from a sensor, not an external data logger connected to the RS-232 port. We should also check the Center Transmission in Window checkbox and log beginning and end of transmission checkboxes. This will center the transmission in the 10-second window and log the transmission parameters. Next, we will be working in the Internal Sensors tab. In the Internal Sensors tab, we can change the label from INT0 to VB. Select the type battery from the drop-down menu. This will be measuring the battery voltage. We want to be measuring the battery voltage once an hour, so we can change the interval to 1 hour. This will set up the GTX to capture the battery voltage every hour at the top of the hour. Next, we will set up the SDI-12 sensors by clicking the SDI-12 Sensors tab. In the SDI-12 Sensors tab, we can enter the address of 1. This is the address of the SDI-12 sensor being measured. I want to set up the first measurement to be the water level taken every 5 minutes starting at the top of the hour. This means that I should change the interval to 5 minutes. And change the label from SDI0 to HG. This will set up the GTX to capture the water level measurement every 5 minutes starting at the top of the hour. The second SDI-12 measurement we must make is the water temperature. We want to take it every hour starting at the top of the hour. This measurement will come from the same SDI-12 sensor used to measure the water level. So that's why the address we will enter is 1 in row SDI1. We must change the value from 1 to 2. This value parameter defines the second returned measurement from the water level and water temperature SDI-12 sensor. I know this is going to be the water temperature measurement. Next, we want to change the interval to once an hour. And we also want to change the label from SDI1 to TW. This will set up the GTX to capture the water temperature measurement every hour at the top of the hour. The third SDI-12 measurement we must make is the air temperature. We want to take it every hour starting at the top of the hour. This SDI-12 sensor is at address 2. We must enter address 2 into the address column of row SDI2. Next, we can change the interval to 1 hour. Lastly, we can change the label from SDI2 to TA. This will set up the GTX to capture the air temperature measurement every hour at the top of the hour. Next, we will be working in the Timed Data Buffer tab. This is where the timed message is set up. The The first time data parameter we can enter is the water level. So under the type column, we can select HG from the drop-down menu. We can change the value count from 1 to 24. Since we're taking a measurement every 5 minutes, 1 hour's worth of data will be 12 measurements. And if we want the past 2 hours worth of data, that has to be 24 measurements. So that's why we're changing the value count from 1 to 24 to get the past hours and the previous hours measurements in every transmission. Next, we can change the field width to 6. The field width parameter is the number of characters used to send the measurement. This includes the sign and the decimal place. The next parameter we want to add is the water temperature, so we can select TW from the drop-down list. We can change the value count to 2, since we're taking 1 measurement every hour, and we want the past 2 hours worth of measurements. Next, we can change the field width to 5. Now we can add the air temperature from the drop-down list. This is labeled TA. Now we can change the value count from 1 to 2, just like for the water temperature, and change the field width to 5, just like the water temperature. Next, we can add the battery voltage by selecting VB from the drop-down list. We can change the value count to 2 and the field width to 6. The next parameter that we can add is the transmit battery voltage. After that, we can add the transmit temperature. Then we can add the transmit forward power. And the last parameter in the timed message will be the transmit reflected power. This will complete the timed message configuration. We can now move back to the Configuration Options tab. Here we can send the configuration to the GTX by clicking the Send Config to GTX button. This will pop up the confirmation dialog box where we can click Yes to save the configuration and send it to the GTX. Now we can click the Enable GTX button. If the system has not already been placed outside, now would be a good time to do so. The location is critical. The system should have a clear view of the sky so the GPS can get a quick GPS fix. And the transmit antenna should be pointed at the satellite. There should not be any obstructions near the antenna which might cause interference. Now we can monitor the GTX status by clicking the Monitor/Inspect GTX button. This will bring up the Monitor/Inspect GTX window. Under the GTX Information tab, we can see that the GTX is enabled and waiting for GPS time. It can take up to 15 minutes for the GTX to get calibrated. Moving over to the GPS status tab, we can see the status of the GPS receiver. In this screenshot, we can see a good example of what the GPS status should look like about a minute after enabling the GTX. Now I've taken a second screenshot about 2 minutes after the GTX has been enabled, and this is a good example of what the status should look like. We can see that the GTX has gotten a fix, but still needs to get the UTC correction. That process can take up to 15 minutes. When complete, the status field should say off, and the last time calibration and TCXO calibration times will be filled in. After all of that is complete, we can move over to the GTX information tab and see that the time to next transmission is filled in. This means that the GTX has gotten a GPS fix and has scheduled the next time transmission. Now if we click on the Time Data Buffer tab, we can see that the Time Data Buffer is waiting to be filled in with data from the STI-12 sensors. Thank you for watching. If you have any questions or comments, please call or email.